Okay, let's see what this question has to say to us. So it says, in a mixture of Skittles and M&Ms, let's call this S, let's call this M, just to, make it easy for us. So in a mixture of S and M, 80% of the pieces are M. Okay, let's try to visualize this a little bit. So there is some type of mixture, okay? And if I kind of do this 20-80 separation, let's say this is 20%, this is 80%. So the question basically is saying that, hey, 80% of the pieces are M's, okay, and 20 are these skitties or whatever the S thing is. A fourth of this mixture is replaced by a second mixture. Okay, so a fourth, 1/4 has been taken out, and some else 1/4 has been introduced into it, resulting in a combination which contains 60% Skittles in a total. Oh, okay. So resulting. So I do not know the concentration of this, whether, okay, so there is no enough information that what type of mixture was added into it. And the only thing that I do know is 1/4 of some mixture, I don't know, this is completely unknown, was added into the previous mixture. And as a result, it landed up with a new mixture, uh, which has only 16% of these S dudes. And what's there going to be? 84? Wait a second. You subtract a 4, you add a 4. Yeah. 84% of these M's and S. And it's asking me what was the percentage of Skittles in the second mixture. So it's basically asking me that, hey, what was the percentage, okay, of S? What is the percentage of S in this second mixture? Let's call this second. Let's call this first. And let's call this the final. Okay. And there obviously there's going to be some M as well, and I don't know the percentage. So guys, I think this question, one thing that needs to be understood over here is kind of like using your intuition. So if I have removed a value and added a new value, which is dropping down this S concentration, so whatever this second concentration or this second beaker is, it is basically dilute in S. And this is the reason why the S concentration has dropped from 20 to 16%. So definitely the concentration is not going to be 20, it's going to be something lower than 20, right? So anything above 20 is already out of the window. Now the question arises is, which one of these four choices might be suitable? So how about, in order to get rid of these crazy fractions, I say this is 100 liter, and over here this is 20 liters of S and 80 liters of M, and 1/4 of this 100 something was removed. Okay, let's try to visualize this. So, so what is the 1/4 of 100? Well, this is going to be, I believe, 25, right? Because you need 4 25s to get to add up to 100. And since out of this 25, 20% is S. So let's take 20% of 25, which is basically the 1/4 which we took out, right? So this is going to be, so this is going to be 4 5s, okay? So this basically can be broken down into two pieces, which is 5 and a 20. So 5 grams are going to be of this what S, and 20 is going to be the weight of this M inside the 1/4 which has been removed. So how much is basically left here? So if I'm interested in getting the leftover, so 20 minus the 5 is basically 15. And what's the 80 minus the 20? I'm left with 60. So now the question is 15 plus what percentage, what fraction is going to give me 16? And on the bottom, 60, what do I add over here, which will give me eventually 84? So now I think it's a simple math problem. This first one is going to be 1. And what's this going to be? 24? So you add a 20, you get 80. You add another 4, you get 84. Yeah, 24. So the final concentration of M ratio, no, sorry. Uh, Final concentration of S ratio M is basically 1 ratio the 24. Okay. And if I do the total, this is going to be 25, right? 25 plus 24. And if actual total, now this is the simplified fraction, guys, the simplified version, not the absolute. The absolute is basically 100% over here, right? Because it is 100 liter. So now the question is, okay, if what do I need? What is the common multiplier here? So the common multiplier here over here is 4. So if I multiply 4 with every single individual, I'm gonna get a 4 concentration or absolute weight of S. And what's this gonna be? 4 fours are 16, 1 Gary, 4 twos are 8, plus 1, 9. Yeah. So the actual so the final mixture, which has, by the way, 100 full liter, it is going to have 4 weight of S and 96 weight of M. And therefore, since the question has only asked me about what is the going to be the percentage of Skittles, answer must be 4. You guys following so far what I just did there? Do you guys have any questions? Anybody? Why you guys are so quiet? What's up? Are you able to hear me?
Yes, APD.
Okay, so you guys have no questions? Should we move on then?
Yes, but for this 25, you use the same ratio like 80 and 20.
80 and 20. I didn't get you. What was your question again?
Like for 25, 1/4 of 100,
Mm-hmm.
uh, we use the ratio like 5 Skittles and 20 M&Ms
Yeah,
is
over here.
because, yeah, it's
Okay.
because of the initial ratio 80 and 20. We
No,
divided into
no,
this
no,
ratio.
no, no. It's not because of the initial ratio. So yeah, it's kind of like because not kind of no, sorry. This is basically given that 1/4 of the original part was removed, which is 25. And 20% of that part is now the question arises, okay, if the 25 1/4, now we are basically not talking in fractions, we're talking in absolute numbers. So if 25 was removed, now the question is how many S did it had or how many M it had. What I used is this, the given percentages. I took the 20% of 25, it gives me 5, and what's going to be the remaining? It's going to be 20 because I need a 5 needs a 20 all the way to get to 25. So in that 25, which is 1/4, I have 5 of S and 20 of M. Now,
Yeah, okay. Thank
okay,
you.
and then I just went to what is left, okay, over here. Sorry, what is left? And I just created this equation that what do I need to do in order to make it 16 over 84. I use this ratio over here to come up with the final concentration, and eventually I was able to find out the 4. You guys following?
Yes.
Okay, cool.